Okay, so last method for this linear differential equation with a constant coefficient that we are going to learn today. Name of the method is method of variation of parameters. Method of variation of parameters. Now this is a completely different method. It is not like a shortcut methods, or it is not like an undetermined coefficient. Already we learned that method of undetermined coefficient. This method of undetermined coefficient is the method uh, that is alternative for these shortcut methods there. Okay, that is alternative for the shortcut methods. But this variation of parameter, this method only works for second order differential equation. You will already observe that differential equation should be of the type a d2y by dx square plus b dy by dx plus cy is equal to fx. Not necessary that all a, b, c should be non-zero. If one of that a, b, c can be b and c can be zero, obviously, is that a cannot be zero, a cannot be zero. So this in some cases b or c can be zero. b b or c can be zero. Okay, just want to replace this cell. Just a minute. So that is one thing. The first thing about it should be a second order differential equation only. You cannot solve first order differential equation or third order differential equation by this method of variation of parameter. So that is one thing. Another thing, now if we have to identify the example of variation of parameter, how we can identify? So we can identify if that RHS, now this is an important thing again. So if that RHS, that is fx, this fx is either say sec x or say cosec x or tan x or cot x or log x or function of e raised to x. Function of e raised to x. Now what is the meaning of function of e raised to x? One of the example I will say 1 upon 1 plus e raised to x. So it is just e raised to x is there, so we can use our shortcut method. We have that for e raised to ax, we replace d by a there, is that? But whenever these things happen in the RHS, like sec x, cosec x, tan x, cot x, log x, or f of e raised to x, then remember we have to use a variation of parameter method. Or in other words, we can say a simple words that whenever shortcut method fail, we have to use the variation of parameter. Is that? Because in shortcut method we have exponential function, we have trigonometric, which is sine and cosine, hyperbolic, sine and cos hyperbolic, and algebraic. If other than these function exist, if other than these shortcut method exists, so obviously we have to use the variation of parameter. But majority of the times, near about in all previous question paper, I'm saying 100% all question papers, the question is already mentioned that solve this example by method of variation of parameter. Okay, so we have to solve that by method of variation of parameter only. So no need to think on that question, because it is already mentioned there. But by chance if it is not mentioned, you should know when to use this variation of parameter method. So obviously when RHS is not than our required shortcut functions, okay, other than that 4 functions, exponential, trigonometric, hyperbolic, and algebraic. Other than that, obviously a variation of parameter. Now how this method works here, whenever we are given a second order differential equation, yes, first we have to find out yc by our regular method. So we already seen what is the method that we have for yc. So find the roots of auxiliary equation, phi d equal to 0. Once we get a root, we can write down its yc as a c1y1 plus c2y2. Then we are going to compute yp. Okay, then we are going to calculate yp. Now we can assume that let yp is a u1 y1 plus u2 y2. See, whatever y1 and y2 will come in yc, they are always a part of yp there. Okay, So we are assuming that yp is this one, where u1 and u2 we have to find out. Main task in variation of parameter is finding this u1 and u2, finding the values of u1 and u2 there. So to get u1, this is the formula. The formula says integration minus y2 fx upon w dx, and u2 is integration y1 fx upon w dx. What is the w? W is known as a Wranskian. W is known as a Wranskian. So what is that Wranskian? Actually, this Wranskian is a determinant of the function and its derivatives. So we have here y1 and y2 in yc, y1 and y2 in yc. So we have to write down first row as y1, y2, and second row are their derivatives, y1 dash and y2 dash. If we evaluate, we get a value of Wranskian. So always this Wranskian is a non-zero. Wranskian is never zero. Okay. So once we get value of w, we have to replace in the integral this as an integrand in the denominator here, and we have to integrate it. So you have to remember the formulas again. Integration minus y2 fx upon w dx, and u2 is integration y1 fx upon w dx there. So in u1 there is minus y2, while in u2 it is plus y1 there. So that about the formulas. We'll see the example, then only it becomes more clear. Any doubt in the theory? Is there any doubt here? No doubts? Yes. Okay, so let me see the numerical then. So the first question that we have is y double dash minus 2y dash plus y is equal to e raised to x log x. Now, some of you may thought of e raised to ax into v form, but we cannot apply that form because we have e raised to ax into v, provided that v is algebraic, trigonometric or hyperbolic. Then only we use that e raised to ax into v form. But here e raised to x into log x is there. So yes, we can take e raised to x outside there, it's not a problem, but later on we have to apply this variation of parameter for log x. So why not apply directly then? Okay, so we are not going to do that way. So in a solution, step number 1, I want yc here. Yes, I want you from you.
The roots are 1 1.
1 1, very good. It is a perfect square, very good. So as a roots are 1 1, so we can say yc will be c1 plus c2x e raised to x. Is it? Someone can written reverse also, c1x plus c2. So both are correct. Therefore, now write yc like this. Don't write that e raised to x separately. I will take like this: c1 e raised to x plus c2 x e raised to x. Now compare this with c1 y1 plus c2 y2. So it should be y1 and y2. Y1 is e raised to x. Is that?
X,
And what about y2?
X e raised to
X.
X.
Correct. X e raised to x. Next step, always calculate Wronskian. Therefore, the value of Wronskian W is a determinant. So first you can write a formula also: y1, y2, y1 dash, y2 dash. Now this determinant y1 is e raised to x, y2 is x e raised to x. Now important task is, what is y1 dash?
E raised to X.
E raised to x itself, correct. What about the derivative of this? Yes, anyone? What's the y2 dash?
X e raised to x plus e raised to x.
Correct. So I will take e raised to x common and will write e raised to x x plus 1. So it is y2 dash. You can apply product rule, first into derivative of second plus second into derivative of first, you will get this one. Now the last part, to get value of Wronskian, evaluate or that expand the determinant or evaluate this determinant. So cross multiply. What is the multiplication here? What is e raised to x into e raised to x? Yes, anyone? What is the value? What is the value of e raised to x into e raised to x?
E raised to twice x into
Correct.
x plus 1.
E raised to 2x into x plus 1 and minus e raised to 2x into x, is it? So out of
Yes.
that, e raised to 2x gets cancelled and we're left with only e raised to 2x. Is that?
Yes, sir.
So that is the end of the first part. First step number 1, we completed YC. From the YC we get Y1 and Y2, which by comparing with the C1 Y1 plus C2 Y2. Then we got a Wranskian, that is a W, which is e raised to 2x. Okay. Now the next part we are going to start for YP. We are going to assume it as a U1 Y1 plus U2 Y2, where U1 and U2 we are going to find out by integration. Okay, so that is the last part then. So this is the method of variation of parameter. At least complete up to here, then we'll move to the next part. So once you complete, tell me, inform me. Those who are interested, note down. Okay, so is on the chat. Okay, done. Very good. Very good, Neil. So let me proceed then. I will delete it. Now for step 2, we can say let yp is equal to u1 y1 plus u2 y2, where u1 is integration minus y2 fx upon w dx. So let me calculate u1 first. Okay. So what is the value of y2? Is it x e raised to x? And what about fx, RHS function? This is the fx. E raised to x log x divided by, what is the Wronskian value? It's e
E
raised
raised
to 2x, correct. And tell me now what will happen?
the UV rule.
No, not UV rule. Before that,
Sir, cancel. Cut
cancel.
will cut
Yes, e raised to x part gets cancelled and then UV rule, correct. Remember, one of the value of u1 or u2, sometimes it is a difficult to evaluate. One is always simple and one is a little bit difficult. Right now we don't know which one is a simple and which one is difficult. That we come to that. So first, right now we came across integration of minus x log x, or minus is outside, or minus x I will keep it. So which should be u and which should be v to use the by parts?
Sir, U log X.
Log x.
Okay, u is a log x and v should be obviously the other. So the integration will come log x u first into integration of second. So I'll say minus x square by 2 minus integration of derivative of first 1 by x into minus x square by 2 dx. I hope it's clear. So u1 will become, I will say u1 minus x square by 2 log x, that is the first term, and you will observe one of the x gets cancelled here and minus minus become plus, so it is a plus there, plus, and it is x by 2, so it is x square by 4, is that? So don't write the constant of integration. It is not that we are evaluating a separate integral. It is actually the formula from the formula we are finding this u1. Okay, so that about u1. So that's the end of u1. Now we have to find out similarly u2. So you should remember this u1. At the end, we are going to replace y1 and y2. y1 is e raised to x, y2 is x e raised to x, and we are going to replace u1 and u2 that we are calculating here. And then, yes, someone, I think, done u2 also. I think, is it Sahitya? It is x log x minus 1. Correct. Okay, very good. So once you finish u1, tell me. So I'll move to the u2 then. Once you complete the calculation of u1, tell me. Or you can try that u2 also side by side. Those who finished. Those who not finished, write it. If you have the doubt, yes, it's welcome. You should ask the doubts. It will become more interactive then. And I also come to know where you have exactly the problem, so we can discuss that more in more detail. Can we calculate u2 then? Done?
Yes, sir.
Okay, so now u2 equal to integration y1 fx upon w dx. So that's a formula. So y1 is just e raised to x, fx is e raised to x log x upon e raised to 2x, and we already observed that e raised to 2x get cancelled everywhere here in both the and integration of log x. You should know the formula. Again, you can use otherwise by parts. Log x should be u and 1 should be v. So first is a log x first into integration of second minus integration of derivative of first into integration of second. So I used by parts here, and we got here x log x minus x. So that about u2. So we have u1, u2, y1, y2. Thus yp will become, which is a u1. So I am not able to remember the value of u1. So I think minus x square by 2 log x plus x square by 4, is it u1, and
Plus
y1 is,
x square,
yes,
sir.
okay, very
Sir,
good.
x square.
Pardon?
Sir, x square. You have written x to the power 4.
Yes, correct. This is x square by 2 4, correct. My mistake, correct. It's x square by 4, and that is this is u1. This entire bracket is u1, and this is y1. So u1 y1 plus u2. U2 is just we calculated here, x log x minus x, or you can take x common, and into x e raised to x. So that about yp. And now at the end, don't forget to write that yc plus yp is a general solution or complete solution there. So that's the method. This one is a variation of parameter. Variation of parameter works on we are converting actually that constant of the yc as a parameter u1 and u2, and we are varying them. So we are varying that. Sorry, we are varying that c1 and c2 as a means converting into the function. Okay, and that's a method known as a variation of parameter. This method mainly works whenever, or this is a mainly we have to use it whenever shortcut methods fails. There we cannot use shortcut method, then should go for variation of parameter. But restriction is it should be a second order differential equation. There are other methods for higher order also. We are not going in that because it's not part of the syllabus. So right now just focus on a second order differential equation. So we'll move to the question number 2 then. Okay? Or someone is writing. Can we move to the next question? Okay, I hope
Yes,
that.
sir.
Okay, thank you. So question number 2, d2y by dx square plus y is equal to tan x. So first you should tell me two things. First is yc and the second thing the value of w. Do a calculation and you can tell me.
Sir, YC is equals to
Hmm? Yes,
C is equals to C1 cos x plus sin x.
c2 cos c1 cos x plus
C2 sin x.
c2 sin. Correct, Neil. Okay, very good. Now tell me value of w, Wronskian. Tell me the value of a w.
One.
Yes, 1. Very good, Saipir. Yeah, correct. So I will show you a solution here. So you'll observe that's a yc. Yc is written as a c1 cos x plus c2 sin x. c1 cos x plus, so y1 is a cos x, y2 is a sin x, and then the value of w. W is the determinant y1, y2, y1 dash, y2 dash. So it is a cos square x plus sin square x, and that is 1. Okay. Now we have to find out that yp, where yp is u1 y1 plus u2 y2. So you can try to find out u1 and u2. Anyone completed the value of u1 or
So U1
u2?
is cos x.
Pardon, u1 is
Cos x.
cos x only.
Yes, sir.
I think not correct, not correct. Oh, the formula for u1 is integral minus y2. Okay, probably you may be correct. Minus y2 fx. So minus y2 means minus sin x into tan x divided by 1. Okay, minus sin x tan x. So how it is cos x, sir? So you get a
Sir,
sin.
U1 is Y1 is cos x, right?
Yes, y1 is cos x and y2 is a sin x. Correct. So you can
So cos x into tan x, so sin x upon cos will get cancelled. So integration of minus sin x is cos x.
but for u1 it is an integration of minus y2 fx dx, na? u1 is integration of minus y2. y2 is here sin x, na?
Okay, okay. So U2 will be cos x then.
Okay, that is okay then. u2 will be cos x because yes, that is a cos x into tan x. So cos gets cancelled. Integration of sine is a cos x. Very good. u2 is a cos x. That's correct. u2 is a cos x. What about this? Anyone able to do u1?
So trying for one.
Pardon?
So trying.
Trying. Okay, still you are trying. Okay, no issue. Take your time.
Then 1 is minus log of sec x plus tan x
Okay, good.
minus sin x.
Okay, once similar, but let me check. Okay. Yes, sin x minus log of sec x plus tan x. Correct, correct. Very good, very good. So that about u1. You will observe u1 is here. I hope you can able to read it. May not be too small there. Otherwise, you can download that PPT and that time also you can see there. So at the end, complete solution is also written. That is yc plus yp. u2 is minus cos x. The integration of sin x is a minus cos x. So don't forget that minus sign also. That about u2. While u1 is an integration of minus sin square x upon cos x. Now sin square can be converted as 1 minus cos square. Separate division 1 upon cos is a sec. So it become integration of cos x minus sec x. This minus sign merge inside the bracket, and the integration of cos x is obviously a sin x, but integration of sec x is a log of sec x plus tan x. You can put modulus sign also if you want. And that about the answer. Just you write on u1 y1 plus u2 y2, so it's little lengthy. So tell me if you completed this. One more last example we are going to see on this method. Mainly you have to do that calculation, but I will show the solution also. So are you finished?
So wait for one.
Yes, yes, no issue. No issue. You can go through it. Take your time.
Sir, done.
Done. Very good. Okay, good. So one last question here. Question number 3. Oh, so I completely forgot it. I think the animated part there. Why complete answer came there. Okay, so you have that YC in front of you. At least you try YP then. So it is d square minus 1. As d square minus 1 plus or minus 1 are the root. So c1 e raised to x plus c2 e raised to minus x. That about a yc. So y1 is e raised to x, y2 is a e raised to minus x. Your y1, y2 can be interchanged. Okay. But remember the final answer that yp will be the same. In between you have little interchange values. That means your u1 can be u2 and u2 can be u1 provided you assume y1 and y2 differently. Suppose your y1 is e raised to minus x and y2 is plus e raised to x. There will be a small change in a solution. That's it. So Wronskian value comes minus 2 now because e raised to x into e raised to minus x, that is e raised to x minus x, e raised to 0x, and e raised to 0 is 1. So minus 1 is a minus 2. That about a Wronskian.
So u1 is log 1 plus e raised to x,
U1 is log of.
1 plus e raised to x.
Okay, I will just check. U1 is integration minus y2 minus y2 fx minus e raised to x upon 1 plus e raised to x. How you? What is the answer you said? U1?
The log 1 plus e raised to x.
Not na, because this is when you say minus y2, it become minus of minus e raised to x na. So it is not e raised to plus x. That can be a u2. Okay, whatever you are saying, that is a u2.
But I have taken y2 as e raised to x.
Okay, so that's I'm saying. So then there is interchange. Correct. If your y2 sorry y2 is e raised to x, then you are correct.
Yes, sir.
Yes, then you are correct. Very good. So y2 is e raised to x, then u1 is a simple, and if y2 is a e raised to minus x, then your u2 will be simple. Okay, so it depends. Now other one. Yes, in this case, one u1 is a u1 or u2 is one of that is a simple, but other is a difficult, little difficult. You have to use the methods of integration properly to get that integration. Generally, we are using which formula? Integration of f dash x upon fx, that is log fx. That is one of the integral you require. Okay, those who are
Done, sir.
okay, done. Very good. So let I show that both u1 and u2, those who not completed. So here is the calculation. You will observe in this case u2 is a simple. u2 become minus log of 1 plus e raised to x. Okay, minus log of 1 plus e raised to x. Why that is? You will observe it is f dash x upon fx. Actually, there is no replacement for t. There is no need to replace as a t. So here e raised to x is taken as a t. So e raised to x dx is a dt. So it is a dt upon 1 plus t log of 1 plus t that way. Or directly you will observe integral of f dash x upon fx is a log of fx that way. But in u1 you will observe we come across dx upon e raised to x into 1 plus e raised to x. Now this creates the problem how to integrate, because to replace e raised to x by some if you think for substitution for e raised to x as a t, so we should have e raised to x dx in the numerator. So to get that, just that e raised to x is added, multiplied numerator and denominator by e raised to x. Now again e raised to x is taken as a t. So if e raised to x is t, that e raised to x dx is a dt. So it is a dt upon t square into 1 plus t. T square into 1 plus t. Now here partial fraction come. This method of partial fraction for integral whenever the denominator of the factors. So a upon 1 plus t plus b upon t plus c upon t square, that is a partial fraction for this multiplication. Values of ABC is calculated separately in rough work, and that is replace a is 1, b is minus 1 and c is 1. Okay. And then the integral of 1 upon 1 plus t is log of 1 plus t. Integral of 1 by t is a log t, and 1 upon t square is a minus 1 by t. That's the integration. Now it is a log a minus log b. So log of a upon b, and replace the value of e raised to x. This become our u1 there. If still you have the doubt, yes, you can ask.